we'll be starting with the operational procedures in the organization, that what are operational procedures and what are the different things that we cover in the operational procedures. Then we'll be talking about the change management, that how, what is change management, how it works, and then we'll be talking into the terms of OSI model, that what is OSI model, how it works, what are the different layers. Then we'll be talking about the network appliances, that what are the different types of network appliances used in an organization, and then we'll be talking about the traffic types, and then so that's what we're going to cover. So let's start from the operational procedures. So first thing that we have is, what is operational procedure? So companies, they also need ticketing systems, asset documentation, and change management procedures to enforce configuration management. And they need safe working practices and to ensure the physical environment does not present any health hazards or risk to electronic devices. Additionally, they need to ensure that technicians and agents represent the company professionally in all customer contact and support situations. Right? So when we are talking about the operational procedures, these are the best practices, safety measures, and professional guidelines that IT professionals follow while performing their duties, right? So there is a term which arrives, which is SOP, Standard Operating Procedure. So employees must understand how to use computers and network services securely and safely, and be aware of their responsibilities. To support this, the organization needs to create written policies and procedures to help staff understand and fulfill their task and follow best practice, right? Now, if I'm talking about, I used the word policy, so how will you define the word policy? So policy is an overall statement of intent, that what my intentions are, how the thing should be followed, right? Now, a standard operating procedure is a step-by-step list of actions that must be completed for any given task to comply with policy. Most IT procedures should be governed by standard operating procedures, right? We have guidelines also. Guidelines are for areas of policy where there are no procedures. Procedure means step-by-step list of actions, right? If there are no procedures, either because of the situation has not been fully assessed or because the decision making process is too complex, and the user should be able to capture it in a standard operating procedure. So guidelines will also describe the circumstances where it is appropriate to deviate from a specified procedure, right? So guidelines, it's not policy, is something which you have to follow. If you don't follow it, there will be some consequences. Guidelines will give you recommendations, that these are the recommended things that you should follow. But if it is getting too much complex for your organization, you may modify it according to yourself. That's guideline, right? Now if we take an example of SOP, right? So let's say there is a procedure for custom installation of software packages, like verifying the system requirements, validating the download source, confirming license validity, adding the software to change control or monitoring process, and developing support documentation, right? That if there is some problem with the software package, or if it throws any error while execution, then what will be the support team doing? So support team will be going through the documentation, and then they will be telling what to do next, right? Or they will be setting up it uh, again, or they will be giving you steps, or they will be following the steps to modify it, right? Then if there is a new user setup, new user has joined the company, so new user setup checklist as a part of the onboarding process for new employees and employees changing job roles. So it includes identification or enrollment with secure credentials, allocation of devices, allocation of permissions, to security groups, what they are allowed to access according to their job role and what they are not allowed to access. All of these things should be in the place, right? So now when we are following a checklist or we are following a standard operating procedure for a new user, what if there is end user termination? If termination happens, then we should also follow a checklist as a part of offboarding process for employees who are retiring, changing job roles, or have been fired. So it includes returning and sanitizing devices, releasing software licenses, and disabling the account permissions. So they should not be able to access anything. Right. Now, in these operational procedures, we have something called ticketing systems. Now, what are ticketing systems? Anyone? So, ticketing system manages requests, incident, and problems. So, ticketing system can be used to support both internal end users and external customers. Right. So, what happens in the ticketing system? User contacts the help desk by phone or email or directly through the ticketing system. A unique job ticket ID is generated, right? And an agent is assigned to the ticket. A ticket will also need to capture some basic details like user information and device information, right? In user information, the user's name, contact details, and other relevant information like department or job role, right? So it might be possible to link the ticket to an employee database or customer relationship management database, right? For device, if relevant, the ticket should record information about the user's device. So it might be possible to link the relevant inventory record through a service tag or asset ID, right? So the user supplies the description of the issue. The agent might ask clarifying questions to ensure an accurate initial description. The agent categorizes the support case, assesses how urgent it is, and determines how long it will take you to fix. Right? The agent may take the user through initial troubleshooting steps like can you check pinging the local host? Can you or check if the wire is properly connected? Can you check if Wi-Fi is turned on? If you can you check the adapter of your system? Anything they may ask you, right? If these do not work, the ticket may be escalated to desk side support or a senior technician, right? That's how ticketing system works, right? Now I told you about the categories in the ticketing system, right? So categories and subcategories group related tickets together. So this is useful for assigning tickets to the relevant support section or technician and for reporting and analysis, right? So service management standards, they distinguish between the different basic ticket types, right? So three of them are there: request, incidents, and problems. Requests are for provisioning things that the IT department has a standard operating procedure for, like setting up new user accounts, purchasing new hardware or software, deploying a web server, and so on. So complex requests that aren't covered by existing procedures are better treated as projects rather than handled through the ticketing system. Then we have incidents. What is an incident? How will you define the word incident? Any event went wrong or any event which went adverse, that is called an incident. So in ticketing systems, the incidents are related to any errors or any unexpected situations which are faced by end users or customers. So incident may be further categorized by severity, like impact and urgency, like minor incident, major, or critical incident, right? Then there are problems. Problems are causes of incidents and will probably require analysis and service reconfiguration to solve. So this type of ticket is likely to be generated internally when the help desk starts to receive many incidents of the same type. So using these types as top level categories for an end user facing system is not always practical. End users are not likely to know how to distinguish incidents from problems. Like, for example, devising categories that are narrow enough to be useful, but not so numerous as to be confusing or slow down the whole ticketing process is a challenging task, right? In ticketing, we also have severity, right? We check the severity. Severity means how much severe it is, how much critical impact it is doing. So severity level is a way of classifying tickets into a priority order. With categories, it will be complex, like whether to keep request at the top or incident at the top or problem is at the top. Because incident happen due to problems, so which should be at the top, problems or incident, right? So there are three severity levels based on the impact, which is critical, major, and minor. Now, minor incidents are not having a significant effect on customer groups, right? Major incidents affect a limited group of customers or involve a suspected security violation. Critical incidents have a widespread effect on customers or involve potential or actual data breach, right? So more discrete levels may be required if the system must prioritize hundreds or thousands of minor incidents per week. A more sophisticated system that measures both impact and urgency might be required, right? So severity levels can also drive a notification system to make senior technicians and managers immediately aware of major and critical incidents as they arise, right? Then we also have ticket management, how it's managed. So after opening an incident or problem ticket, the troubleshooting process is applied until the issue is resolved. At each stage, the system must track the ownership of the ticket, who is dealing with it, and its status, what has been done, right? So this process requires clear written communication and it might involve tracking through different escalation routes, right? So if we talk about escalation, we have escalation levels, right? So escalation occurs when an agent cannot resolve the ticket, right? That's where escalation happens to senior, then again the higher senior. So the incident is related to a problem and it requires analysis by senior technicians or by a third party support service, right? That's one of the reason. Second reason can be the incident severity needs to be escalated from minor to major or major to critical and now needs the involvement of senior decision makers, or the incident needs the involvement of sales or marketing to deal with service complaints or refund requests, right? So the support team can be organized into tiers to clarify the escalation levels, right? Like we have, let's say, tier 0, self-service options for the customer to try to resolve an incident through advice from a knowledge base or a bot, right? Then happens tier 1. Tier 1 connects the customer to an agent for initial diagnosis and possible incident resolution. Then we have tier 2. Tier 2 allows the agent to escalate the ticket to senior technicians. Tier 2 internal or to a third party support group, external. Then there is Tier 3. Tier 3 escalates the ticket as a problem to a development team or engineer or to senior managers and decision makers. So the ticket owner is the person responsible for managing the ticket, and ticket owner can keep on changing if the ticket is moving from one tier to another, right? So when you are escalating, ownership might be reassigned. Whatever system is used, it is critical to identify the current owner. The owners must ensure that the ticket is progressed to meet any deadlines and that the ticket requester is kept informed of the status, right? And there should be clear written communication, as I said, right? So free form text fields allow ticket requesters and agents to add descriptive information, right? So normally there are three fields to reflect the ticket life cycle, like one is problem description, right? Progress notes, problem resolution, right? So problem description means it records the initial request with any detail that could easily be collected at the time, right? Progress notes record what diagnostic tools and processes have discovered and the identification and confirmation of a probable cause. Problem resolution sets out the plan of action and documents the successful implementation and testing of the plan and full system functionality. So it should also record end user or customer acceptance that the ticket can be closed. At any point in the ticket lifecycle, other agents, technicians, or managers may need to decide something or continue a troubleshooting process using just the information in the ticket, right? So tickets are likely to be reviewed and analyzed. It is also possible that the tickets will be forwarded to customers as a record of the job performed, right? Maybe feedbacks will be taken from the customers. Consequently, it is important to use clear and concise written communication to complete description and progress fields, right? So clear means using plain language rather than jargons. Concise means using as few words as possible in short sentences. State the minimum of fact and action required to describe the issue or process, right? That's what ticketing system is, and that's how it works. Then in operational procedures, we have asset management as well. How will you define asset? What is an asset, guys? So asset means anything that holds value for you. Now there are two types of assets: tangible and intangible. So tangible means anything that you can touch or feel and it holds some value for you. So it can be any hardware like your mobile phone, your laptop, anything it can be, right? That's tangible. Intangible means something which you cannot touch or feel, right? But still holds some value for you. Intellectual property, right? Software licenses. You cannot touch or feel them, but if it's stolen, then that will be a problem for your organization, right? So asset management uses a catalog of hardware and software to implement lifecycle policies and procedures for provisioning, maintaining, and decommissioning all the systems that underpin the IT services. It is very important for an organization to have an inventory list of its tangible and intangible assets and resources. So tangible inventory should include all hardware that is currently deployed as well as the spare systems and components kept on hand in case of a component or system failure. Intangible asset inventory includes software licenses, data assets like intellectual properties, right? So when we are talking about these assets, so we have database systems. So there are many software solutions available for tracking and managing inventory. So an asset management database system can be configured to store details like model, type, serial number, right? Asset ID, location, users, value, and service information. So an inventory management suite can scan the network and use queries to retrieve hardware and software configuration and monitoring data, right? Then we have asset tags and IDs. For an inventory database to work, each instance of an asset type must be defined as a record with a unique ID. The physical hardware device must be tagged with this ID so that it can be identified in the field. Asset tag can be affixed to a device as a barcode label or RFID sticker. Barcodes allow for simpler scanning than numeric only IDs. An RFID tag is a chip which is programmed with asset data. So when it is in range of a scanner, the chip powers up and signals the scanner. The scanner alerts the management software to update the device's location, as well as asset tracking. This allows the management software to track the location of the device, making theft more difficult. Right? Then we also have network topology. So we create network topology diagrams. So diagram is the best way to show how assets are used in combination to deliver a service. So a network topology diagram shows how assets are linked as nodes. A topology diagram can be used to model physical and logical relationships at different levels of scale and detail. So in terms of physical network topology, a schematic diagram shows the cabling layout between host, wall ports, patch panels, switches, router ports. So schematics can also use to represent the logical structure of the network in terms of security zones, how you have broken the network into smaller parts, right? And then we have asset documentation. So an asset procurement lifecycle identifies discrete stages in use of hardware and software, right? You have change procedures. So change procedures approve a request for a new or upgraded asset, taking account of impacts to business, operation, network, and existing devices, right? We also have procurement. Procurement determines a budget and identifies a trusted supplier or vendor for the asset. Deployment does what? It implements a procedure for installing the asset in a secure configuration, right? Then maintenance. Maintenance means it implements a procedure for monitoring and supporting the use of asset, right? And disposal, it implements a procedure for sanitizing any data remnants that might be stored on the asset before reusing, selling, donating, recycling, or destroying the asset. Then we have types of documents. So what we have discussed SOP, standard operating procedure. So that is also a type of document. Step by step instructions for routine tasks, define rules, tools, and expected outcomes, ensure consistency and compliance across teams. Right? Then we have work instructions. Now, what can be work instructions? Detailed guidance for specific task within a process. It includes visuals or screenshots. It's more granular than SOPs. Then process checklist. Bullet point list to track task completion. It is useful for audits, onboarding, and daily operations. Right? Then policy and procedure documents. So it defines rules, standards, and compliance requirements, and it is often tied to legal, regulatory, or organizational mandates. So it provides a framework for decision making. Then we have process narratives. So high level descriptions of how a process works. It includes goals, constraints, and dependencies. It is useful for training and stakeholder communication. Right? So these are some of the documents that work together to create a repeatable, auditable, and scalable operational environment. Then we also have a document which is called KB. KB stands for knowledge base. So a knowledge base is a repository for articles that answer frequently asked questions and document common or significant troubleshooting scenarios and examples. So each inventory record could be tagged with a cross reference to an internal knowledge base to implement self-service support and to assist technicians. Clear? Next thing that we have is change management. What is change management? It refers to policies and procedures that reduce the risk of configuration changes causing service downtime. And change management is closely related to configuration management, right? So in configuration management model, we have ITIL, IT infrastructure library. So it is a popular documentation of good and best practice activities and processes for delivering IT services. Under ITIL, configuration management is implemented using different elements like service assets. What are service assets? These are the things, processes, or people who contribute to the delivery of an IT service. Then there is configuration item. So configuration item is an asset that requires specific management procedures for it to be used to deliver the service. Then we have config baselines. Configuration baselines are the settings that should be applied to the configuration item to ensure secure and reliable operation. And the last is performance baselines. So performance baselines are metrics for expected performance to provide a basis for comparison for ongoing monitoring of a configuration item. The main difficulty in implementing a workable configuration management system is in determining the level of detail that must be preserved. So this is not only evident in capturing the asset database and configuration baseline in the first place, but also managing moves, adds the and changes within the organization's computing infrastructure, right? So in change management, why it matters? Because it prevents downtime from untested updates. It ensures accountability, who made the changes and why. It provides a rollback plan if things go wrong. It keeps stakeholders informed, right? And it supports compliance with industry regulations or industry standards, right? Now, when we are talking about change management, so we have a change management process where there are multiple steps. So first we have request for change, or we also call it change request. Change request is generated when a fault needs to be fixed. A new business needs or processes are identified, or there is room for improvement in the existing standard operating procedures or system, right? The need to change is described either as reactive, where the change is forced on the organization, or as proactive, where the need for the change is anticipated and initiated internally, right? So in a formal change management process, the need or reasons for change and the procedure for implementing the change are captured in request for change form, and it is submitted for approval, right? What that document should include: first, purpose of change; second, scope of the change. Now, purpose of the change means this is the business case for making the change and the benefits that will accrue. It might include an analysis of risk associated with performing the change and risk that might be incurred through not performing the requested change. The scope of the change, this is the number of devices or users or customers that will be affected by the change. Scope can also include cost and time scales. For a complex project, it might include subtasks and stakeholders. Scope should also include the factors by which the success or failure of the change can be judged, right? Then impact analysis and approval happens, right? So change approval means when change request has been drafted and submitted, it must go through an approval process, right? So we have change board approvals. So if the change is normal or minor, approval might be granted by a supervisor or department manager. Major changes are more likely to be managed as a dedicated project and require approval through change advisory board, right? The role of the change advisory board is to assess both the business case and the technical merits and risk of the change plan. So the change advisory board should include stakeholders for departments, users, or customers who will be impacted by the change, as well as those proposing it, technicians who will be responsible for implementing it, and managers, directors who can authorize the budget, right? Then in this same thing, a risk analysis happens. What is risk analysis? Anyone? Risk? Great. So risk is anything which is a probable situation. It may happen, it may not. Right? So if I'm holding a glass of water over my laptop, the water may spill over my laptop, it may not. There is a risk, right? I'm investing money in share market, so the money I may lose or I may get a profit, right? That's a risk. So for the change advisory board to approve a change, it must be confident that risk analysis has identified both things that could go wrong and positive enhancement that will be made from completing the change. So risk analysis, it is a complex and demanding skill, but in simple terms, it has two approaches: quantitative and qualitative. Right? Quantitative risk analysis calculates discrete values for the impact and likelihood for of each factor affecting the change proposal. Qualitative risk analysis seeks to identify and evaluate impact and likelihood factors through previous experience and informed opinion to replace or supplement metrics. So the outcome of risk analysis is the assignment of some risk level to the change request. So this could be expressed as a discrete value or as a traffic light type of indicator where if there is red, there is high risk, orange means moderate risk, green is minimal risk. So if the change is approved despite a high level of risk, stakeholders must be informed of these risks, right? So that they can anticipate and react to them appropriately as the change management project proceeds. Then you will be planning for the change, that what things you will need for the change. Then you will plan uh, the rollback plan, that if there, like during the change, if you are making changes to the infrastructure, you are making changes to any services, if something bad happens, do we have enough ways to roll back to the older one which is currently we are using, right? So that is what, that is the planning part. Then there is test and implementation. So test and implementation means when a change is approved, a responsible staff member is appointed to manage implementation of the change. Now the implementation of change must be carefully planned with consideration of the impact on affected systems. For most significant or major changes, organizations should attempt to test the change first. So it might involve sandbox testing. That means in a computing environment designed to replicate the production environment, but isolated from it. The change implementation in the production system should be scheduled at an appropriate date and time to minimize the risk of system downtime or other negative impact on the workflow of business units that depend on the IT system being modified. Most organizations, they have a scheduled maintenance window period for authorized downtime. Stakeholders should be notified in advance if there is risk of downtime. Every change should be accompanied by a rollback plan so that the change can be reversed if it has harmful or unforeseen consequences. Right? Then there is something called end user acceptance. As well as the technical implementation, the change plan must account for end user acceptance. So it can be difficult for people to adapt to new processes and easy for them to magnify minor problems into major complaints of the it worked before kind, right? So there are three principal strategies for mitigating these risks. First is change requests should be considered by stakeholders on the change board who represent end user or customer interest. A project that will have significant impact should incorporate user acceptance testing to allow end users to work with the updated system and suggest improvements before release. Training and education resources must be available before the change is initiated. So the support team must be ready to deal with incidents arising from the change as a priority, right? Then you will be documenting the changes, whatever changes you have made, wherever in the organization you have made the change, and you will review it. The whole team will review it if there are any changes in the documentation, and that documentation will be kept in the organization when next change will happen. So this documentation will be reviewed first, and after reviewing this documentation, the new change request will be. Next we have is OSI model. Now, OSI model is basically a model to understand how the data is sent from one computer to other. So that's a part of a network. Now, network means where millions and billions of devices are communicating with each other to share data, to communicate, to share videos, audios, anything it can be, right? Now, when we talk about network, in network, we have something called internet. What is internet? Internet is the biggest network, internetworking. Now, there are two things, internet and internet. Is there any difference between these two? The one which you are using, World Wide Web, the whole internet, Google, Gmail, everything, that's internet, right? Internet with uppercase I shows your actual internet, right? The internet with lowercase I, that is a small network with at least two devices communicating with each other, and it is in a room only, not more than a room. So not even local area network, even less than, because local area network can be in a building also. Internet is inside a room only with lowercase I, with the devices communicating with each other. That's internet with lowercase I. And then there is intranet. Intranet means local area network or internal network of an organization, which is accessible only by the employees of the organization, not to anyone else. And then there is extranet. What is extranet? Extranet is an extended version of intranet where the vendors, or you can say guests, can connect. So it is a guest network. So if you have some visitors in the organization for some uh, let's say product showcasing, so then if you have to give access to them, so you give them the access of extranet, right? Now when we talk about networking, the very first thing we have to understand is how the data moves from one place to another. And for understanding that, we have a model called OSI model. OSI stands for Open Systems Interconnection Model, and it is a referential framework, right, which is not used exactly in our internet, but we use it for understanding how the data is transferred from one place to another. It has 7 layers. Every layer has its own working. Can anyone name all the 7 layers of it? Great. So we have 7 layers, and these are the 7 layers of your OSI model. Everyone was correct. Now, if someone is not remembering or is not able to remember the name sequentially, you can use a mnemonic. please do not throw sausage pizza away. So if you remember this mnemonic, you will remember the names of the OSI model layers sequentially. Please do not throw sausage pizza away. Right? Now, the layer 1 of our OSI model is said to be physical layer. And the layer 7 of the OSI model is called application. Why so? Because application layer is the closest layer to the user, then why application is not layer 1? Why physical is layer 1? Communication starts from physical layer. Okay. But if I'm sending an email to you, so it's starting from the application layer. Then so to access the application layer, I need to go like, yeah, that's also something, a myth that I want to remove, guys. That people say that application layer is layer 1 from the sender side and physical layer is layer 1 from the receiver side. That's not the case. From both of the sides, layer 1 is your physical layer. So you have a computer, you power on your computer, right? From where? You plug it in a switchboard, you power it, you switch it on. The current flows through the physical layer, that means the wires. Then it goes to your CPU, right? In CPU, multiple things happen. The data is also converted. Then a session is created. The operating system is loaded, right? Then IP address you also get. Then of MAC address you already have, that is also checked, and then you get the last thing as the welcome screen of the Windows or whatever your operating system is. So that's why application layer is the last thing. After powering on the system, the last thing you are able to see is application layer. Application layer is not the first thing you are using, right? First, the current is traveling from the physical layer, right? That's why physical layer is layer 1 of the OSI model. Now, every layer in these 7 layers has their own working. Like application layer is GUI. Whatever the user is able to see, that is application layer. Then we have presentation layer. Presentation layer does the encryption of data, encryption and decryption, right? Apart from encryption, what is encryption? Encryption means changing the data into a format which is not readable. Apart from encryption, it does the compression of the data so that the data uses less bandwidth, and it also does what? Converts the data into a format so that other layers can understand. Session layer takes care of session management. Session management means when the session is starting, when it will be closed, and how it will be going smoothly. Then there is transport layer. Transport layer does the segmentation of data, and also it takes care of ports, right? So there are two protocols in transport layer which are used, TCP and UDP. TCP stands for Transmission Control Protocol, UDP stands for User Datagram Protocol, and TCP is called Connection Oriented and UDP is called Connectionless. Why? Because TCP sends acknowledgement. That's why it is called reliable, right? Why it is reliable? Because it sends acknowledgement. That means it assures you that your 100% data will be delivered to the target. but it's relatively slow as compared to UDP. UDP is connectionless, no acknowledgement, non-reliable, but fast. Right. So the transport layer decides for sending this type of data whether to use TCP or UDP. Now think of it. Why you need a protocol which is not assuring that your 100% data will be delivered to the target? Why you need UDP then? We want 100% data to be delivered to the target, right? Faster communication. But in faster communication, you are losing packets. That's absolutely fine for us if we are losing packets. Why? Because TCP always sends acknowledgement. Acknowledgement means that it will be basically acknowledging every single packet. Now think of it, you are on a video call with your family or friends, and every second you are speaking a word, you are getting a pop-up on your mobile phone screen, message sent or frame sent every single second you're getting. Isn't it annoying for you? Second thing, we want faster speed, we can afford the packet loss, right? I want my voice to reach you guys, but I can afford the packet loss. If there is some problem in the network in between and you're not able to hear me, you will ping me that can you repeat, and I'll repeat that. But we cannot afford slow speed, that first I will speak, then few seconds later you will hear it, and then again I have to wait for a while, and then again I have to speak the next line. So this webinar would be of 4 hours instead of 2, right? So that's the problem. That's why we need UDP as well, for streaming, for watching videos, for uh, communication, right? Now TCP transport layer take cares of whether to use TCP or UDP, and it does the segmentation of the packets. That means it will break your data into smaller parts. Now why breaking of data is necessary? Because if I am sending 100 MB of data at the single time, a packet whose size is 100 MB, right? If it gets lost due to some error in the network, so I have to send 100 MB again, right? But if I break these 100 MB into 10 MB packets, 10 MB packets, right? So if one of the packet will be lost, I have to send only 10 MBs, not the whole 100 MB again, right? So that's why segmentation is needed. Then network layer works with the IP address. IP address is what? IP address is the logical address of your network. That means it tells where you are sitting right now, in which network. It does not tell which in which device you are sitting, it tells in which network you are sitting. So if I'm sending some data to you, it is reaching to your network, that means to your router. Then from your router delivers the data to the device in which I want to send the data, right? That's IP address. Then data link layer works with MAC address. What is MAC address? Physical address of the device. So MAC address tells exactly which device I want to send the data. This is the address of your network interface card. Then it also helps in error control. Now error control means that it will check whether the data sent by the sender, whether it is correct or it has been manipulated by someone, or due to some electromagnetic interference it's manipulated. So it will, that thing will be checked by the data link layer. Then we have physical layer. So physical layer does what? Physical layer will convert the data into digital or analog format depending upon the medium you are using, whether you are sending data through wire or wirelessly, right? So if I am sending some data, let's say hello I'm sending, right? So it will be encrypted at the presentation layer. So it becomes ELHLO. Then session layer will start a session with the receiver session layer. Transport layer will break it into smaller parts, right? Then network layer will add the IP address, source IP address, and destination IP address, and then the first segment, that means E, right? This is called packet, right? Then that packet will be sent to the data link layer. Data link layer will add destination MAC address, source MAC address to the packet, right? This is called frame. This frame will be sent to the physical layer. Physical layer will send it to the physical layer of the receiver, and then the receiver's physical layer will convert it into the format so that other layers can understand. Then the data link layer will check the destination MAC address and source MAC address, that if destination MAC address written in the message is matching to my MAC address or not. If it is matching, then it will accept, remove this portion, and send the rest of the things to the network layer. Network layer will check the IP, that if destination IP is matching to mine or not. If destination IP is matching to mine, then this packet is for me, and then it will send the segment E to the transport layer. Now same thing will happen to all the segments, and transport layer will wait for all the segments to arrive at the transport layer. Once all the segments have arrived at the transport layer, then transport layer will reassemble all the segments, send it to session layer. Session layer will close the session, send it to presentation layer. Presentation layer will decrypt the encrypted message, send it to application layer, where the receiver will be able to read the message, whatever was sent, right? So that's how. Next, we have network appliances. So what are network appliances? Network appliances are dedicated hardware devices which are designed to perform specific network related functions. So they improve performance, security, and management of data flowing across networks. Now we use different network appliances, like back in the old days we used hub. Now hub is what? Hub is a not so intelligent device which basically broadcasts the data. Broadcast means sending the data to everyone. So if four devices are connected with each other, and device number 1 wants to send some data to device number 4, and in between there is a hub, right? So device 1 will send the data to hub will distribute it to everyone, that whomsoever's data it is, pick it up. So device 3 will check that whether it has like my IP and my MAC address written. No, it's not mine. 2 will also check whether my IP and MAC address is written. No, that's not mine. 4 will say yes, my IP and MAC address is written. So it will accept the data. But there were some attacks, some sniffing kind of attacks on the hub. So attackers were doing what? They were changing the working of their network interface card. So the network interface card was not checking any IP and MAC address, and it was accepting every single data, right? So that's why this hub is now legacy. It is not used. We use switch. Switch is a smart device. Why? Because it has a brain, and that brain is called ASIC, application specific integrated circuit. And this ASIC chip is also used in modern days robots, right? So what this switch does, it has a table called CAM table, content addressable memory table, right? Now in this table, it's written the MAC address and port number, right? MAC address A, port number 1, MAC address B, port number 2, MAC address C, port number 3, MAC address D, port number 4, right? So if device 1 wants to send data to device 4, what will happen if there is a switch in between? Switch will go to the CAM table, check. Okay, A device with MAC address D is connected to port number 4. So it will send the data to port number 4 only, not to others. Right? That's why switch is smarter as compared to hub, and that's why we use switches nowadays. Then we have a router. What router does, which switch cannot? Switch can communicate inside a network, but not outside a network. Right? So router is a networking device that connects multiple networks together and directs the data packets between them. So it acts like a traffic controller, deciding the best path for data to travel from one network to another, especially between your local network and the internet. Right? So it assigns the IP address to the devices. It does network address translation, convert the private IP to public IPs, right? So a device like your laptop sends the data packet to the destination like google.com. So the packet reaches the router through Wi-Fi, right? Router checks the packet's destination IP address. It consults its routing table. So it has what? Routing table where the path are written, which is called IP routing table. The path where to go next is written, not the destination, where to go next, right? So it will check the routing table to decide where to send the packet next. If the destination is within the same local network, it sends it directly. If it is outside, it forwards the packet to the internet service provider's router, right? And when the destination replies, the router maps the response back to the correct internal device, right? So that is a router which allows multiple devices to communicate with each other. Then we have firewall. Now what is a firewall? So a firewall is a security system. It can be either hardware, software, or both, that monitors and controls incoming and outgoing network traffic based on rules. Think of it as a security guard at the gate of your network. It checks every packet which is trying to enter or leave and decides whether to allow it or block it, right? So the traffic arrives at the firewall. It could be from the internet or a local device or another network. It checks the source IP, destination IP, port number, protocol, the data, right? So if it is written, I have written the rule, let's say block all traffic from network 192.168.1.0 on port 23, right? So if it matches any allow rule, it passes through it. If it is matches any deny rule, it is dropped or locked, right? So all the traffic coming from this network or from this subnet will be dropped, right? The firewalls that we used from the very starting was packet filtering firewall, right? Packet filtering firewall means it will, you can write the rules on the basis of IP and port number, that on which port number which IP should be blocked. Then there was stateful firewall. It tracks the active connection and context. So if a connection is started properly, like we have something called three-way handshake, right? How the connection is starts. So it has SYN, then SYN ACK, and then ACK, right? So if this process is followed for starting the connection, the firewall will not check the packets coming after this. It will just check that the person who is connecting has followed the proper protocol, and it will allow every single packet. It won't check any packet, right? Then we have application firewall. Application firewall is used in application layer. It filters traffic based on application level data like HTTP, FTP. So we have heard of uh, web application firewalls, right? So these web application firewalls, they are basically the application firewalls, right? So that's a firewall. That's how you define firewall. Then we have IDS and IPS. IDS stands for intrusion detection system, and IPS stands for intrusion prevention system, right? So intrusion detection system monitors network or system activity for signs of malicious behavior or policy violations. So it captures packets or logs, it compares them against known attack signatures or behavioral patterns, and it sends the alert to the admin or SIM tools, security information event management, like Splunk or IBM QRadar, right? Intrusion prevention system, it is also called active IDS. So intrusion prevention system does everything IDS does, but it also blocks malicious traffic in real time. So it sits in line between the source and the destination, inspect the packets before they reach the target, drops or modifies the packet based on the rules, right? So what IDS does, only detects the suspicious activity. IPS detects and actively blocks, right? So that is your IDS and IPS. Next, we have traffic types. So in networking, traffic refers to the flow of data packets across a network. So different traffic types describe how data is sent from a source to destination. So we have unicast. Unicast means one-to-one communication. That means when one system is sending data to other system. That is unicast. Then we have broadcast. Broadcast means one to all. That when someone is sending data, it will send to all the devices in the network, whether they need it or not. Right? Then we have multicast. Multicast means one to many. So it means one to many, one not one to all. Just think of it like your newspaper subscription. So if you are subscribed to your newspaper vendor, every morning your newspaper vendor will give newspaper to you. If your neighbor is not subscribed, then your neighbor will not get that newspaper every morning, right? So there is a multicast group in the server. So if the device is a part of that group, so the device will receive the data. Otherwise, even if the device is in the same network and not the part of that multicast group, the device will not receive any data, right? That is multicast. And then arrives your anycast. Anycast means one to nearest, right? So if I am sending some data, let's say there is a server who is sending some data. Now nearest to that server is device 1, then there is device 2, and then there is device 3. So the server was having nearest device as device 1. So server sent the data to device 1. Device 1 sent it to its nearest to device 2. Device 2 sent it to its nearest device 3, and device 3 received the data. That is anycast, one to nearest, right?